this point our model is built, and if we run the simulation we can see that the piston moves due to gravity, sort of like a pendulum. This is a three-dimensional animation, so if we rerun it from this angle we can see how it is moving. The next thing that we'll do is, instead of just having this move due to gravity, we're going to drive it using a Simulink signal. So I have a test vector that I've defined for another model, and I'll simply pull it into this model to drive my piston. We're going to actuate this joint, so to do that I'll need to add a couple extra ports and then use a joint actuator in order to drive this joint with the Simulink signal. We can drive joints using forces and motions. So if I go into the joint actuator, I can select a force or a motion. For this example, I'll use a motion. So I've now prescribed the motion of this joint. If I rerun the simulation, we'll see now the piston moves not due to gravity, but due to the motion that we have prescribed. We'll want to measure values from our simulation. So in order to do that, we're going to use a joint sensor to measure the amount of torque that is required to produce this motion. We'll go back to the Sensors and Actuators library, get a joint sensor, and connect it to the joint. So now at this point we can go into the joint sensor and see what values we can measure: angle, velocity, acceleration. For this example we'll use computed torque. So this will tell us how much torque it takes to produce the motion we've described. I'll then go back up to the Simulink library to get a Simulink scope so we can view these results on a scope. Now when we run the simulation, we see the animation and we can see what the value of the computed torque would be.